Hey guys, welcome to the video on the discriminant. So we're going to talk about the discriminant. So the do now that we had in class was just to write down the quadratic formula. So in case you don't remember what that is x is equal to, and we had a little story for it, the negative boy was undecided to attend the radical party, and where the squared bouncer took away 4 alcoholic containers, that's an A. The party was all over 2A, leave off the M. Or if you just want to memorize it straight through, it's negative b plus or minus the square root of b squared minus 4ac. Our objective for today is given an understanding of quadratic formula. Students will use a discriminant to recognize the number of roots. So students will use the first blank is going to be the discriminant to determine the roots. So we can write that down. Discriminant to determine the roots of quadratic equation. So here's the quadratic formula again. We wrote this in our do now. And we're going to start with the discriminant. So the discriminant is actually just what is inside our quadratic formula, or our radical. So here I gave you guys the entire quadratic formula. Really the only thing we care about is this part of it. So this part of it would be the only thing we care about. This is known as a discriminant. So if we were to analyze 3 different cases, we get our first case. It says if b squared minus 4ac is greater than 0, this greater than 0 just means positive. So if it's positive, then we're going to get 2 roots, or 2 real roots. If my discriminant is equal to 0, then we get 1 root. And the last one is if my discriminant is less than 0, well, all my numbers less than 0 are my negative numbers. So if it's negative, then we get 0 real roots. So let's see why that's the case. When it's positive, we're going to have an example up here. We'll say negative 4 plus or minus, and the square root, something positive inside, so let's say 36 over 2. If we have an example like this, if this is positive, then we're going to have this plus or minus situation, which means we get negative plus or minus 6 over 2. That gives you 2 roots, negative 4 plus 6 over 2 and negative 4 minus 6 over 2. So that's why we obtain 2 roots. Now let's look at a scenario when the discriminant is equal to 0. So now let's say, for example, negative 4 plus or minus, and my discriminant is 0 over 2. Well, the square root of 0 is 0, so we're really just left with negative 4 over 2, which is just negative 2. We get 1 root. And last, let's look at an example with my discriminant negative. So negative 4 plus or minus the square root of negative 36 over 2. We can't take the square root of a negative number at this point because we have not covered imaginary numbers yet, which is something to come in next video. Check out the next video. So this does not exist yet. So these are 3 different cases or 3 different possibilities. Now let's visually see what each one of these roots looks like if I were to graph them. So if I were to graph this parabola when my discriminant is positive, my parabola would cross my x-axis twice, giving me 2 roots. If I were to graph when it's equal to 0, we get to 1 root, so it may look like this, where it just barely touches it once, or I like to say it kisses my x-axis only once. And then the last example is it won't even touch my x-axis. So we saw these 3 cases both analytically or numerically, and we also saw what it looks like graphically. So again, it's 2 sides of teaching. So I'm showing you guys the visual representation of these solutions and also the algebraic. So whichever one you guys prefer, it's all good to me. So we're going to look at the very first example. We want to find out what our discriminant is, or I'm sorry, how many roots we have. And again, our discriminant is in charge of finding out the number of roots each quadratic function has. So this is already in standard form and it's set equal to 0. So we're good to start working with this problem. We need to find out what our a value is, our b value, and our c value. My a is 1, my b is -8, and my c is 17. We're going to plug into my discriminant. Again, my discriminant is just the b squared minus 4a deal. It's what's inside our radical. So I'm going to plug in directly and see what we get. We get -8 squared minus 4a, my a value is 1, times c is 17. So if we work this out, we actually get 64 minus, so if we multiply out -4 times 1, we get -4. And -4 times 17, is -68. So we're going to go ahead and write that -68. This gives us, when we evaluate, a -4. So now my discriminant is -4, which means if we look back in our previous notes, anytime our discriminant is negative, we have 0 real roots. So to answer the how many root question we have up here, well, our discriminant is -4, we're going to have 0 real roots, and we're done. So again, you guys can pause and review as many times as you guys need, as long as we kind of get it down. So let's take a look at example 2. I'm actually going to take a look at excuse me, let's look at the green one. It is the most challenging one, so you guys have the option to kind of look at the other ones as well. So the green one, again, I'm going to set what my a is, my b, and my c. My a is 25, my b is -30, and my c is 9. I'm going to plug in directly into my discriminant for ac, or b squared minus 4ac. So if I set up just a shell so you guys can see what I'm plugging in, the 4 is constant, we plug in an a and we plug in ac. My b, if we look down here, is just -30. My a is going to be 25 and my c is 9. So I'm going to evaluate this out. -30 squared is 900. -4 times 25, that's -100 times a 9. We simplify that just a little bit further. We get 900 minus 900. My discriminant is 0. So I still want to answer how many roots. If I look back to my previous notes, when my discriminant is 0, so we're saying when this thing is equal to 0, I have 1 root. So again, this is what we evaluated, and it was equal to 0. We have 1 root. So for this answer, it would be 1 root. And that's how we would do it. If you tried working out the other ones, let's go ahead just for fun, knock them out. A is equal to 1, B is equal to -8, C is equal to 16. If I plug that into my discriminant, we get that my B value, -8 again, squared, minus 4 times the quantity of 1 times the quantity of 16. We get that my discriminant for this one is also going to be 0. If my discriminant is 0, we again obtain 1 root. And the last one is A, B, and C. My A value is 1, my B value is 3, my C value is -2. If I were to plug this into my discriminant, I end up getting B squared, which is 3 squared, minus 4 times 1 times -2. And we end up getting 17. My discriminant is 17, which tells me that I get 2 roots. Excuse me. So we saw all these 3 examples. We obtain 1 root when it's 0 and 2 roots when it's positive. And our very first example, we obtain a negative, which means 0 real roots. So we saw a case of each one of these. So just to sum it up, let's do just one final one. You guys can pause now if you want and then work it out and then just check your answer. But I'll go through it fairly quickly. We got an A, a B, and a C. -1, -8, 15. We're going to plug into our discriminant. So we get negative 8 squared minus 4 times the quantity of 1 times the quantity of 15. We get 64 minus 60. This just gives me a 4, positive 4, which means I get 2 roots. And that's it. Alright guys, this was a quick little lesson. I hope this helps. Again, this is strictly for you guys. I hope you enjoyed. Later.